Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amnisha binti Jalil and my matrix number is 306650. And now I'm going to demonstrate the working prototype of our system. We will execute the source code and show how the system perform add, update, cancel and refund operations, which are the core features of our system. I'm going to start with the add button. So to add a new booking, the users must enter the student ID, select the booking date, start time and duration. Optional add-ons such as record rental can also be selected. When the add button is clicked, the booking is saved and displayed in the table. Also, for the add button, the system includes input validation. So, if the user click the add button without filling in the required field, the system will display an error message asking the user to fill in the required information. This helps to prevent invalid data being stored into the database. Next, for the update button, the user must select an existing booking from the table and then edit the booking detail and finally clicks the update button. The system will update the booking information and reflect changes immediately. If the user clicks update button without selecting a booking from the table, the system will prompt the user to select a record first. Similar to add function, update function also includes input validation. If the user clicks the update button without filling in the required fields or without selecting a booking record, the system will display an error message. This ensures that incomplete or invalid data cannot override existing booking information. So next I'm going to explain about the cancel button. So the cancel button works similarly to the update button. The user must first select a booking record from the table before clicking the cancel button. If no booking is selected, the system displays an error message prompting the user to select a booking. So this will prevent accidental cancellation of the wrong booking. Lastly, for the refund button. So actually the refund button follows the same validation process as the update and cancel function. Again, a booking record must be selected from the table before a refund can be processed. If no record is selected, the system will display an error message requesting the user to make a selection. This actually helps to prevent accidental or invalid refund actions. In addition to record selection validation, the refund function also enforces a business rule. Only bookings that have been cancelled are eligible for refund. If the user attempts to refund an active booking, the system will display an error message. This ensures that refunds are processed correctly and follow real-world booking policies. Now I'm going to explain about the source code for the add button. So firstly, the method starts by establishing a database connection using dbconnection.getConnection. The system will retrieve the student ID and validates that both student ID and booking date are not empty. If validation fails, an error dialog is displayed and the insertion process is terminated. Then, the selected booking date is converted from java.util.date to java.sql.date for database compatibility. And the start time and duration are retrieved and the finish time is calculated based on the duration. The system will check whether record rental is selected and stores the result accordingly. Next, an SQL insert statement is prepared to add the booking record into the database with status set as book. After successful insertion, the table is refreshed and the input form is cleared. And the information message is displayed to inform the user that the booking has been added successfully. So next, we are moving to the update button. So first, the system will check if a row is selected in the booking table. If no row is selected, again an error message is shown and the update process is terminated. And then the database connection is established using dbconnection.getConnection. The selected booking ID is retrieved from the table, and the system validates required inputs fields such as student ID and booking date. The booking date is then converted to java.sql.date for database compatibility. The start time and duration are retrieved, and again the finish time is recalculated. And then the record rental option is captured based on user selection. An SQL update statement is prepared to modify the booking detail. And after successful execution, the table is reloaded and the form is cleared. A confirmation message is displayed to indicate successful update. Next, we are moving to the cancel button. Again, the system will check if a booking record is selected in the table. If no record is selected, the cancellation process is stopped and an error message is displayed. The booking ID is retrieved from the selected table row. A database connection is established again using dbconnection.getConnection. An SQL update statement is executed to change the booking status to cancel. The booking record is retained in the database to preserve booking history. The database is reloaded and the input form is cleared. Finally, a success message is displayed to inform the user that the booking has been cancelled. And lastly, for the refund button, again the system will check whether a booking is selected in the table or not. If no booking is selected, the refund process is stopped and an error message is shown. The system will check if the selected booking status is cancelled or not. If the booking is not cancelled, the refund process is stopped. The booking ID is taken from the selected table row. A database connection is created again using dbconnection.getConnection. The refund details are saved into the refund table. The original booking record is kept for record purposes. The table is refreshed and the form is cleared, and finally a success message is displayed after the refund is completed. Next, I'm going to explain about the database. So as you can see from the picture, a database named BCBS_DB is created to store the system data. So the booking table stores booking information such as student ID, booking date, time, and status. Each booking record has a unique booking_ID as the primary key. The refund table stores refund information for cancelled bookings. Each refund record has a unique refund_ID as the primary key. The booking_ID in the refund table is used to link the refund to its booking. A foreign key is used to maintain the relationship between booking and refund records. So booking records are not deleted to preserve booking and refund history. And then the system select the BCBS_DB database. The booking table is modified to add a new column named record_rental. So the record_rental column stores whether a record is rented or not. The default value is set to no if no record is rented, and then the existing booking record are not affected by this change. Next, the system uses the BCBS_DB database again and remove all existing record from both the refund and booking tables. This operation clears the data stored in the table while keeping the table structures intact. It is mainly used to reset the database for the testing or demonstration purposes without dropping the table themselves. And lastly, the system will use the BCBS_DB database again and execute a select store from booking query to display all records stored in the booking table. The result grid shows complete booking details including booking ID, student ID, booking date, start time, finish time, booking status, and record rental information. This allows the user or administrator to view and verify all booking records currently saved in the system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Narsika Najwa binti Abdul Rahim, matric number 306561, and I will continue presenting the system testing. So, for the system testing, we use equivalent partitioning to divide input data into valid and invalid classes. This helps reduce the number of test cases while still covering all possible input conditions. So, we have 8 test cases. Number 1 is student ID. So, for the student ID, valid input must be numeric only, such as 202312, and the valid inputs include alphabetic characters, alphanumeric values, blank input, and symbols. So, this ensures the system correctly validates student ID entries. So, number 2, we have booking dates. The booking date is valid when a date is selected. So, if no date is selected, the input is considered invalid and should be rejected. Then number 3, we have start time and duration. So the start time must follow a valid time format such as 10:00 AM, and invalid format like 00 PM are rejected. So for duration must be a positive integers while 0 or negative value are invalid. Then number 4, we have record rental. For record rental, valid options are yes or no, and any random or unexpected tag is considered invalid. Number 5, we have booking selection. A valid case requires a booking row to be selected, such as booking ID 5. So if no row is selected, the system should display an error message. Next, number 6, we have booking status. So valid booking status include cancel or book. So this ensures the system process booking action correctly. Next, number 7, we have booking ID resets. After deleting all records, the booking ID should reset to 1, and if the ID continue incrementing, it is considered as an invalid behavior. And for the last one, we have form field. After a successful booking, all form fields should be clear, and if previous data remain, it is considered as invalid. Next, I will explain the IEEE test case format, which provide a detailed structure including test step, expected result, actual result, and recommendation. So, we have number 1, valid student ID. This test verifies that a numeric student ID is accepted. The system successfully add the booking and the result match the expectation. Next, we have invalid student ID. This test check non-numeric student IDs. Even though an error message was expected, the booking was added successfully. So, this indicates a validation issue, and we recommend adding numeric validation. Number 3, we have empty student ID. When the student ID field is left blank, the system correctly displays an error message. Number 4, we have booking without date. If the booking date is not selected, the system correctly prevents the booking and display an error. Next, number 6, we have record rental. When record rental is selected, the system correctly saves the value as yes. Number 7, display booking records. All existing booking records are correctly displayed in the table when the system is launched. Number 8, update booking. This test confirms that selected booking can be updated successfully. Number 9, no selection action. When update, cancel, or refund is clicked without selecting a booking, the system correctly displays an error message. Number 10, cancel booking. Cancelling a selected booking correctly change its status to cancelled. Next, number 11, we have refund cancelled booking. The system allows refunds only for cancelled booking and process them successfully. Number 12, reject refund for active booking. If the booking status is still booked, the system correctly rejects the refund request. Number 13, booking ID reset issue. This test failed because the booking ID continued incrementing After all records are deleted, we recommend resetting the auto-increment value in the database. And lastly, we have clear form after booking. After a successful booking, all form fields are cleared as expected. So we have several steps for manual testing. Step 1 is test preparation. The system was launched using NetBeans and the MySQL database connection was verified. Tables such as booking and refund were populated with sample data and test cases were prepared using equivalent partitioning. For the step 2 is test execution, where the action performed during testing are entering student ID, selecting booking date, start time and duration, choosing record rental option, and clicking buttons like add, update, cancel and refund. And we also observe system messages and booking table updates. Next, for the last step, result observation. The expected result were compared with the actual result and each test case was marked as pass or failed and any mismatch were recorded. So here the table of test case execution example. As you can see, TC001 passed because the booking was saved successfully using a numeric student ID, while TC002 failed because the system accepted a non-numeric student ID. Same goes to the TC013 and TC014. TC013 failed because the booking ID did not reset after deleting all records, while TC014 passed as the form was cleared correctly. So this is the pie chart of the testing result. As shown in the chart, 85.7% of the test case passed while 14.3% failed. This indicates that most system functions work correctly with a few areas needing improvement. This slide shows a recommendation table based on the failed test cases. For TC002, numeric-only validation is recommended for the student ID field, and for the TC013, the database auto-increment value should be reset after deleting all booking records. In conclusion, most test cases pass successfully providing the system is functional and reliable. However, a few improvements are needed especially for student ID validation and booking ID reset. This enhancement will further improve system accuracy and usability. So that's all from us. Thank you.